Okay, so if we just now copy another sample question. So I am taking the example this time from the Aleks review that I created for you. So, and then again, I want to keep the order the same as the test. So when you sit down for the test, the first question on the test is gonna look like this. Oops, oops, what happened? I didn't copy it. Edit, copy, and then Control V. All right. So the first question, it's asking for the end behavior of this function. This is number one on the test. So I'm gonna just put the number before the question. Number one on the test says, determine the end behavior of the graph of this function. It's n of x is equal to -2 parentheses x plus 1 times 3x minus 1 to the third power times x plus 5. All right. Now, can you guys help me? What's the first thing I'm going to do here? We need to find the ultimate degree, right? We need to find the ultimate degree and the ultimate leading coefficient. So for n of x, the function, do we care about the -2? Do we care about the -2? Yes. So we're just going to copy it. Okay. We have an x plus 1. Which one do we care? X. We just care about the x. We just need the x, right? So I'm going to take the x in a parentheses. Next one is 3x minus 1 to the third power. Which one only do we care? We only care 3x, but here 3x is getting raised to the what power? Third power. And on the last one, x plus 5, what's the only thing we care? X. Okay. This simplifies my work, but I still have to work a little bit longer here. I have a -2. I have an x. Now we're going to raise 3x to the third power. So 3 to the third power, if you multiply 3 times by itself, 3 times 3 is 9. 9 times 3 is 27. And x to the what power? Third power. And then the final thing I need is here, x. Now, when we multiply all these things, -2 times 27 is a -54. X times x cubed times x. What am I supposed to do with the powers? Add them up. So we have a 1, we have another 1, and we have a 3. 1 plus 3 is 4. 1 more is 5. So I finally have the degree and the leading coefficient for n of x. Its degree is 5, which is an odd number. And its leading coefficient is -54, which is a negative number. So now you need to go to your chart, or you have to go to your memory, and you have to remember what happens if you have an odd degree and negative leading coefficient. You start high and you end low. So on the test, you will circle an answer choice which it says up, left, and down, right. If this was a test question, for this one, you will just choose up, left, and down, right. Yes? Any questions for number 1? Everybody understands what's happening here? Yes. Now, I'm going to pause here, and I'll give you a question to try. So I do one, you do one, okay? So we're going to now here put extra number 1. So I'm going to label it extra question 1. And I want to just come up with some random question. If I give you h of x is equal to -7 x to the 8 times x plus 1 to the third power times x minus 2. I want to pause this. What do you think? How many of you think that it's down, the answer? It is down, down. Okay, now let's get started. Do we need the -7? Yes. Do we need x to the 8? Yes. From x plus 1, which one do we care? X, and we're going to raise x to the what power? Third power. And from x minus 2, which one do we care? X. The only number we see here is -7, so there's nothing else to multiply by. So we're just copying the x. And then copying the -7. So for x's, what's the ultimate power? 8 plus 3 is 11. One more is 12. So here, the degree is 12, which is a even number. And the leading coefficient is -7, which is a negative number. Now, what kind of end behavior do we get if we have an even degree and negative leading coefficient? Down, down. So if this shows up on the test, you will pick for this question down left and down right. Yes? Is it easy now? Yes.
So in the previous question, we did 3 to the power 3.
Yes, because here we cared for the entire 3x. But here, all we had was x's. We didn't have numbers inside the parentheses, so we didn't have to raise them.
Why didn't we do like 7 to the power?
8 power, very good question. Look, if it was -7x to the 8 power, then I would also raise -7 to the 8 power and x to the 8 power, okay? But if -7 is separate and this 8 only belongs to the x, so this 8 has nothing to do with -7, okay? Any other questions? Are we all good with number 1? Can everybody answer number 1 correctly on our upcoming test now? Please, that's one of the easiest questions. Okay, now we go back to number 2 on the test review that I gave you. So let's go. Number 2 was about giving 1, 0. They were giving us 1, 0 for the polynomial function. So let's just copy this one. So if we have this function here, the test is going to give us this function. This is my number 2. Control V, and then move this. And then the test is going to tell me that here, -2 is a given 0. So -2 is a 0. And we're going to find the sum of the other solutions. So first, we're going to find the other zeros, and then we're going to find the sum of these zeros. So question is, find the, if -2 is a given 0, find the sum of all 3 zeros. So the question is, we have a function given, and they're telling me that -2 is a 0. We're going to find the remaining 2 other zeros, and once we find the answer for the remaining zeros, we're going to find the sum of all these 3 zeros. All right, who's going to get me started? What happens? We're going to do synthetic division with -2 because we want to reduce the degree of this function, right? So let's get started. I have 4x cubed. What number do I need next? 37. Next. -5. Next. -126. And then we're going to make this division symbol. And what number goes here? -2. If it was with x, then we will change the sign. If no x is given, we just copy the number they gave us, right? Okay. What happens to the first number? We copy it. 4 times -2 is -8. Add them up. 29. 29 times -2 is -58. Add them up. -63. -63 times -2 is +126. Add them up. 0. What does this 0 represent? It's a remainder, right? It's a remainder. So that's a good sign. But now we have to generate a brand new function from these numbers, right? So if the main function was f, let's call it g of x now. G of x starts with 4, but what will be the exponent? 4x squared plus 29x minus 63. So this is now a quadratic function that we need to find the zeros of. We need to find the solutions, right? And the best way to solve this problem is by using factoring. So let's try to factor this. 4x squared, how can I break it down? 4x and 1x. If it doesn't work, I have to change it as 2x times 2x, right? But I want to first try 4x times 1x, because when I multiply them, they give me a 4x squared. Now, I need to separate 63. What is 63? 7 times 9 is 63, right? So I'm randomly putting the 7 here and randomly putting the 9 here. But I know that one of them has to be negative, one of them has to be positive. So when I multiply them, I get a negative 63. But I still don't know if this is correct. Now I have to do the butterfly to check if this is correct. So when I do the 4x and positive 9, this gives me a positive 36x. When I do the negative 7 and x, it's a negative 7x. When I combine these two things, what do I get? 29x, and it's a positive 29x. Is that what I see here? That means I placed them correctly. If it doesn't work, I just have to change the location of the things, okay? So what's the first factor here? 4x minus 7. The other factor is x plus 9. What's going to happen to each of these factors? We will set them to a 0. So take the 4x minus 7, set it to a 0. Let's solve this together. How can I solve this for x? Plus 7 on both sides. 4x is 7. What happens next? Divide each side by 4. So the answer is 7 over 4, right? So let's start listing the zeros here. First 0 was given in the problem. What did they give me as a 0? In the problem, you're right. They gave me a negative 2. Second 0, we just solved for it, and we got the second 0 as 7 over 4. We have just third 0 left that we have to solve for. Third 0 will be coming from x plus 9. So x plus 9 is the last factor. I need to set this to a 0 and subtract 9 from each side. So x is equal to what number? Negative 9. So this will be the last 0 that I need in this problem. Now, remember on the test, they want you to find all of these, and what do they want you to do with them? Add them up. They want the sum. So we're just going to add. So since they want the sum of all these 3 zeros, we're going to add the negative 2 with negative 9. And then once we have the answer to this, we're going to add the 7 over 4. If I add these two negative numbers, that's a negative 11. And then that's 7 out of 4. Again, in order to add a whole number by a fraction, we have to get them in common denominators. Therefore, I will have to multiply this one by 4, so it will become negative 44 over 4. And then now I can add it with 7 over 4 once the denominators are matching. So it's going to give me a negative 37 over 4 as the answer to this question. This is how you do number 2 on the test. Any questions here? All right. So, yeah.
But will the answer be fraction?
The answer is a fraction.
On the test.
Yes. it's a fraction. Because I was trying to make them as close as the final exam question, and final exam question is also a fraction. So
Will you give us a separate review for the final exam?
final exam, yes, I'm going to create a review for the test, so you will practice them before you take it. Okay, so let's move to the next question. So next question is about vertical asymptote and horizontal asymptote. Since the questions on this Aleks review is not very close to what you're going to see on the test, I believe, I would like to write that question in my head instead of giving you, yeah, see, but we can still take it. This is question 6 from the review I created on Aleks. I couldn't find exactly the same thing as the test. So this one is question 3. Question 3 is, identify the asymptotes. So we have 2 asymptotes, vertical asymptote and horizontal asymptote. So for this question, we're going to find both vertical asymptote, which we can shorten as VA, and we're going to find the horizontal asymptote, which I can shorten as HA. Okay. So we want to find the vertical asymptote and horizontal asymptote for 2x squared minus 5 over x squared. For vertical asymptote, where do I look at? The bottom, right? What do we see at the bottom? X squared. And what number do we set this to? 0. When does x squared becomes equal to 0? When x is what number? 0, right? If x is 0, when you square it, it still gives you a 0. So x equals 0 is called what? X equals 0 is called the vertical asymptote, right? X equals 0 is called the vertical asymptote in this question. So vertical asymptote is all about the x value, which makes your denominator equal to a 0. And then here, the only problematic number is 0. When x is a 0, your denominator will be a 0, and x equals 0 is your vertical asymptote, right? Now, for horizontal asymptote, do I look at the top or do I look at the bottom? We have to look both, right? So the top has a power of what? 2. The bottom has power of 2, which means they are the same power, right? Whenever they have the same power, horizontal asymptotes, they always start with y equals, right? How many x squares we have at the top? 2. How many x squares we have at the bottom? 1. What is 2 over 1? 2. So y equals 2 is called the horizontal asymptote. Horizontal asymptote is y equals 2, x equals 0 is the vertical asymptote in this question.
You said how many what did we have on top?
The degree is 2 at the top and degree is 2 at the bottom. So how many x squares we have at the top? 2. How many x squares we have at the bottom? Just 1. Therefore, we have to make a ratio between 2 over 1, which is just 2.
Because it's 2x squared, not just regular x squared.
Okay. Yes. All right. What if on the test, I give you this question in this format? Let's just write a, let's say another number 3. So what if I gave you a function like f of x is equal to x squared minus 16 over x squared plus 25. So for this question, again, I want you to find the vertical asymptote and I want you to find the horizontal asymptote. So if I give you x squared minus 16 over x squared plus 25, how do you find the vertical asymptote? How do you find the horizontal asymptote? Anybody wants to share the answer with me? Yeah,
X
Lily.
equals -5 and X equals 5.
What do you think? Okay, all right, perfect, perfect, perfect. Okay, now, Lily, your answer will be correct if this wasn't a plus 25 here, if it was a minus, right? If it was a minus 25, I can factor it, right? But since it is given to me as positive, I'll take the denominator, set it to 0, right? When I set this to 0, there is no real number. When you solve this, you get 5i and negative 5i. So this means the denominator will never be a 0 with the real numbers, will never be a 0. That means there will be no vertical asymptote because you will never get a 0 in your denominator for any real numbers. There's no x, which makes your denominator equal to a 0. Therefore, this question has no vertical asymptote, right? But for horizontal asymptote, both of you got the right answer. The degree at the top is 2. The degree at the bottom is 2, which means they have the same degree, right? Horizontal asymptotes, they always start with y. How many x squares we have at the top? 1. How many x squares at the bottom? 1. So that means y equals 1 is the only horizontal asymptote in the question. And this question is unique and special because this question has no vertical asymptote because the denominator never becomes a 0. Yes? Okay, easy? All right. That's our number 3 on the test. Now I'm going to move you to number 4. So let's just move to the Aleks review. On number 4 is about multiplicities. So I'm going to find the question on the review. Number 4 is the multiplicity question. This one. Find the zeros and the multiplicities. And then we want to label this as question 4. So for this question, we want to find the zeros of this function, and we want to find the multiplicities. All right. Is there anybody who's ready to answer this after we went over this question in college algebra class as well? How do you find the zeros? Let's start from the x minus 2, right? Does x minus 2 give me any 0? 2, good job. So 2 is a 0 with a multiplicity of 3, good job. Because the exponent associated with this number is just 3, right? Okay, so we're done with this guy. X minus 2 is out of the game. With this one, we used it. So what does x plus 1 give me? Negative 1 is a 0. And what is the multiplicity? 1. If there's no exponent here, if there's no other number, it means it's 1. So we also used x plus 1. Do we have another 0 here? Which one? 0. Good job. So 0 is a 0 too. And what is the multiplicity for 0? 2. Good job. Multiplicity is 2. And this is how we do this question on the test when we see it. Super easy, right? This was not easy.
0 because there's only an x in
Yes, yes. This is a multiple choice. And on the test, when I was creating it, I only put 2 answer choices. So there's only option A for this or option B. So there's not even a 25 chance that you're going to get it right. There's a 50% chance that you're going to get it right on the test. Because when I was creating it, I made a mistake. Instead of A, B, C, D, I only made A and B. Okay? for all both versions. Yes.
I don't know, like 50 questions.
No, just for this one.
Oh.
No, the other ones I did it right. But for number 4, because I think the question was long, when I saw it long enough, I thought I have the 4 options. But then when I printed it, I saw there's only 2 options here, but it's okay.
But one of them is the correct answer.
Yes,
Okay.
yes, of course. Otherwise, I would have to change it. And I checked if one of them is right answer, and it was, so I was happy. Okay, so should I give you another number 4 to try, or you guys are good? Yes. So let's hear. I want to just, I think I can go to an example button. And the example button gives me something super similar. Edit, copy, and then now close this. So let's call this another example 4. So question says, find the zeros of this function and state the multiplicities. Okay. Now this time, you guys are telling me the answer and I'm writing it down. The order is not important, by the way. You can give them the zeros in any order you like. The first one is 0. 0 is a 0. And its multiplicity is 4. Good job. Multiplicity is 4. All right, next. Negative 2 is a 0. And its multiplicity is 3. And finally, positive 1 is a 0. And its multiplicity is 1. That's how you do these questions on the test. I hope everybody can get them right. If you have any questions, please feel free to ask.
How many questions is this?
1, 2. 2 questions like this.
Are they both the AB?
No,
or is it
just
this?
one of them.
Okay.
Just one of them. All right. So let's go to now number 5 on the test. Number 5 on the test is about listing the possible rational zeros. So I'm gonna close the explanation. How do I close the explanation? I'm gonna close the explanation, and then we wanna find a question where it says list all possible, yeah, this one. List possible rational zeros. So I'm gonna copy this, and then this is question 5 on the actual test. Question 5. And then the question says, list the possible rational zeros. So we have a function given, and we want to list the possible rational zeros. Since we just did this in college algebra, let's try to remember how do we give them the possibilities for the rational zeros. What number do I look at first? The last number. The sign doesn't matter, so we just have a 6. We can divide the 6 by 1. We can divide the 6 by 2. We can divide the 6 by 3. We can divide the 6 by 6. These are called factors of 6. Once we're done with the last number, what's the only other number we care? The first one, which is 4. We can divide the 4 by 1. We can divide the 4 by 2. And we can divide the 4 by 4. Now, the list will be ratio between these factors, right? Okay, let's stick with 1. If we stick with 1, 1 divided by 1 is 1. 1 divided by 2 is 1/2. 1 divided by 4 is 1/4. So we're just taking the 1 and dividing by these 3 numbers at the bottom, right? And it gives us 3 different factors. Now, we're going to do the same thing with number in line. What's the next number in the line? 2. 2 divided by 1 is 2. 2 divided by 2 is 1, but it's already here. We don't have to repeat it. 2 divided by 4 is 1/2, but it's already here. We don't have to repeat it, right? Next number in line is 3. We are ready to start with the 3. 3 divided by 1 is 3. 3 divided by 2 is 3 over 2. 3 divided by 4 is 3 over 4, 3/4. Next one is 6. 6 divided by 1 is 6. 6 divided by 2 is 3, but it's already here. We don't repeat it. 6 divided by 4 is the same thing as 3 over 2, so we don't have to repeat it. So these are the numbers which will be the list of the possible rational zeros. And you're going to have 2 questions like this on the test about possible rational zeros. Yes. Yes, they're already in order. Yes. All right. Any other questions for number 5? All right. So next question on number 6 on the test is about the synthetic division. So we're going to find our synthetic division problem. It's a question looks like this on the test. So I'm going to just copy this. This is our now number 6. We came to number 6. And then this is Control V, select. Okay, so we want to divide -7 plus 2x plus 3x cubed minus 4x to the 4th power, and we want to divide this by x plus 1. What is wrong about this question? Yes, for synthetic division, first, we have to put this in correct form. Which one needs to go first? -4x to the 4th needs to go first. Then which one comes? Plus 3x cubed. Next, we will need plus 2x. And then, oh, by the way, this one has an extra thing that we didn't think. There is no x squared, so what do I need to put? 0x squared plus 2x. Last thing I need is 7. And we're dividing this whole thing by x plus 1. So the order is really important. And whenever a term is missing, we have to put a 0, right?
How do we know what is the order?
Look here, what's the highest power?
Oh, okay.
4. 4 goes first, then 3 comes. 2 is missing, so we have to put 0x squared. Then we jump to the 2x and then the number. So what number do we need first? -4, and then +3, 0, 2, and what's the last thing I need? Okay, what number goes here? Good job. We will always have to change the sign here if it is coming with an x. What happens to the first number? Bring it down. -4, we just have to copy. -4 times -1 is 4. Add them up, 7. 7 times -1 is -7. Add them up. -7 times -1 is +7. Add them up. 9 times -1 is, add them up. This is the remainder, right? Okay. So on the test, this will be the answer. The answer we will have to write is, okay, if the question has 4th power, the answer will have 3rd. So what am I going to write? -4x cubed plus, nope, what's the number? 7x squared, next, minus 7x plus 9 plus -16 at the top and X plus 1 is at the bottom. So this is how we express the remainder. We put the remainder with a plus sign, but the number goes at the top and X plus 1 at the bottom.
So in the test, you want us to write a plus sign because
Yes.
on Alex, it usually just wants it to put.
No. On the test, because it's multiple choice, it comes with a plus and the negative numbers at the top. Okay? Any questions about the synthetic division? Always, the remainder is always a plus. Yes. Any question with number 6, the synthetic division?
You mean like right after the 9?
Yeah, right after the 9, this will be always a plus because we have some remainder. Okay? Shall I go to 7 or do you need another example like 6? All right, you guys have this assignment now. You can just practice it as many times as until you see me on Wednesday. If any of them is still giving you trouble, you can bring that specific questions on Wednesday and we can practice them again, right? So let's go to now number 7. Number 7 is another end behavior question. So number 7, and I want to find the question, looks like the test question, which was about end behavior. Yeah, it's this time we don't have to find the degree and we don't have to find the leading coefficient on the test. It is given, everything is given, it's already organized. So it's gonna be a question looks like this on the test, number 7. We don't have to find the degree, we don't have to find the leading coefficient. So if you look at this question now, if you have -1/2, x to the 6th power, 4x to the 4th, minus x cubed plus 8, what is the end behavior of the graph? What's the first thing you have to check? Degree is, what number is degree? Degree is 6. Is it an even number or an odd number? Even. So in your mind, automatically you need to reduce your options to 2 options, right? It's either up, up, or it's gonna be down, down, right? Okay, now the leading coefficient is -1/2. So we don't care what number it is, but we only care that it's a negative number. So what will be the end behavior? It's gonna be down and down. So on the test, you will choose down on the left and down on the right. Yes? Is this easy? Number 7 is easy? Anybody has any questions with 7? I'm just going to study one last question before we call it a night today. Number 8, the inequality problem will be the last one we're doing today. Number 8. So here it is on the next page. Number 8 on the test. It's going to look like a question like this. It'll say, solve the rational inequality and what we need to solve is x plus 4 over x plus 1 is greater than or equal to 0. So we want to solve this rational inequality, which is x plus 4 over x plus 1 is greater than or equal to 0. All right. Who remembers what to do first? We draw a number line. Perfect start. We draw a number line. And what happens on this number line? Good job. We need 2 numbers. The number which makes the numerator equal to 0. So the numerator equals to 0 when x is a -4, right? So this makes me a 0. And then denominator becomes a 0 when x is what number? -1. But -1 doesn't make the function a 0. -1 makes the function to be a undefined, right? Because -1 is in the denominator. So this is an undefined number. This is a 0 number. So -1 can never have a bracket in our answer. Never have a bracket. Okay. How many regions do we have now? 1, 2, 3. What do we do with these 3 regions?
Test them.
We test them. So let's get started here. What number is a good test number here? Test what? -5. Let's plug it into the main problem. So in the main problem, If you add a -5 and 4, what do you get? -1. If you add the -5 with +1, what do you get? Negative. So what's negative divided by negative? It's a positive. So that means this first region, every time we pick a number here, we're going to get a positive answer. Is it a good thing? Is that what we want actually? Yes, because this question wants greater than a 0. So it wants the positive regions, right? Okay.
Is there gonna be a bracket?
Very good, very good. So this is going to be a bracket because we want to be also equal to 0. Now the middle region. In the middle region, what number do we want to test? 0 is not here because they're both negative numbers. We can do -2. If we test -2, -2 plus 4 is positive number. -2 plus 1 is negative number. If we divide a positive number by a negative number, what do we get? Negative. That means every time we pick a number from the middle region, we will get a negative answer, which means this is not the region we're interested in, right? Because this generates a negative number. Finally, we want to test the third region to see what kind of answer it gives us. So what number is good to use here? 0 is in that region. Very smart choice. 0 plus 4 is positive. 0 plus 1 is positive. Positive divided by positive is positive. So that means every time I pick a number from the third region, it gives me a positive answer. I am ready to set up my answer. So I'm going to give them whenever we are positive or we are equal to a 0, right? So you guys are helping me. What does the solution set start from? -infinity, comma, -4. Is -4 a parenthesis or a bracket? It's a bracket because we can be a 0. Good job. Union. -1 is parenthesis or a bracket? Parentheses because this makes us undefined, comma, infinity. Infinities are always parentheses, and this will be the solution for this question for the rational inequality problem. Any questions, guys, for this one?